In today's video, we're going to talk about exhaust. Now, some people have said I'm a little apathetic about the exhaust side of things. That's really not true. I just don't care. But we really need to talk about exhaust, because if you're building any kind of performance motor, you are going to have to address the issue. And way back when, they used to tell us you had to have a ratio between the intake and the exhaust. You know, and believe it or not, back in the 80s, they used to say it's got to be like 60% because you're burning so much of it. Well, it then became 70-something percent, 74%, then 86%, and now I'm seeing some people say 90. That doesn't matter. None of those numbers matter. I don't even look at the percentage. I don't even flow the exhaust side on most heads anymore because I don't see the point. As long as you have halfway decent exhaust flow, you're going to be fine. And anybody that ports knows it's way easier to get exhaust flow than it is intake flow. The port's usually straighter, it's short, you know, a decent seat configuration, decent valve size, you're on your way. It's done. So, if I'm not looking at percentage, why is that? Why do I feel like I do? Well, one of the things we need to talk about is the way the intake and the exhaust work are substantially different. Trying to look at some sort of percentage of gas or percentage of flow is a moot point. They work so differently, it doesn't matter at all. On the intake side, at best, naturally aspirated, you're going to have 14.7 psi pushing the air in. You might form a perfect vacuum down here, highly unlikely. So you're actually going to have less pressure differential across the whole system than 14.7. If you're at altitude like I am, that's only 12.5. So why is that different than the exhaust? Well, remember, we blow down the exhaust in the combustion cycle. We don't wait till bottom dead center to move the exhaust. We blow it down sooner than that. So the piston is still descending and we're opening the valve and the pressure in the cylinder is pushing the gas out. And that pressure could be, depending on the horsepower you're making, could be 800 psi, maybe 1,000 psi, somewhere up there. Substantially more pressure than is moving the air on the intake side. Plus, you don't have fuel in it. It's a hot gas. It's technically still kind of expanding. And so all of this is working in your favor to get it out. Now, in general, with the blowdown and the piston moving up, if you say this is 9-to-1, you are going to lose 90% of that volume just with the piston moving up. So you're going to get at least 90% of the gas out no matter what. The only thing you're then worried about is this 10% up here. If it's 10-to-1, 12-to-1, 14-to-1, your percentage is dropping. This becomes maybe 7, maybe 6%. It's not a great volume. Now, do we want to try and generate a bit of a vacuum in here? Yes, as best as you can. But remember, the first goal is to actually get the exhaust gas out. And that is why we blow down early. We don't wait to bottom dead center. Now, if you look at camshafts, most cam companies will tell you, well, we want to bias the camshaft to the exhaust side. If you're running a little cam, say 210 duration, you'd want like 220, 225 maybe on the exhaust side. You want a little more duration on the exhaust side. And that is because it's going to help the blowdown. Now, I know some of you are saying, well, it's really about the overlap. It's about the overlap. That's where the power is made. No. Get over that. This is not where power is made. This can help you a little bit, but this isn't a primary thing. The main thing by adding duration to the exhaust is the blowdown. And this is also why a lot of times advancing the cam that 4 degrees will help. You're moving that blowdown point out a little bit. And basically, with a little cam, like we were talking about, like a 210, we do not have an early enough blowdown. And any dyno test you see showing how you really want split, you know, you really want an exhaust split, you want more exhaust duration, usually they're showing you with a little cam. Now, a little cam is more important to have exhaust split than a big cam, because one of the questions that has come up, some people have questioned both the cams I've shown in some of my videos, the one we're going to test on a stocker motor and the big cam that I want to run in one of the bigger motors, were both reverse split cams. They had less exhaust duration than they had intake duration. And they're questioning why that is. Because most cam companies will say, well, no, you need more exhaust than you need intake. You always want at least 10 more degrees, you know, if not 20. Well, the problem with that view is that as the cam gets bigger and bigger, you're dipping in here further and further. This is not a linear curve. This is an exponential curve. The first 10 degrees with the little cam, yeah, that gained you some and you probably needed it. As you go up in cam size, it becomes less so because you're dipping further and further into the power stroke. You are blowing down at a higher and higher pressure. And so you don't necessarily need the same exhaust on a really big cam, or you don't need to bias it on a really big cam as you do a little cam. Now, especially on the one cam I'm talking about in the stocker motor. The stocker Cadillac's only 300 horsepower. And we're only trying to get it to like 400 and something horsepower with just a cam change. Well, I don't need a whole bunch of exhaust duration and a whole bunch of overlap to make that happen. I mean, you can get 400 horsepower with some other head mods and some flow in intake and basically almost stock cam, something that's just a little bit bigger. So in order to carry that exhaust out, I don't really need it in that case. So you have to look at what you're trying to do. Now, the goal with all of this is, like I said, to get the exhaust gas out. Now, the reason I don't have any real math up here is because some of this doesn't really work well with math. Now, there is math out there if you want to build the perfect header. And something like Pipe Max might help you. Tell you where the steps need to be, how long the runners need to be, how long the steps need to be, what the collector size might need to be. And if you're doing racing, that's worth pursuing because you can gain some power up at the top. But on a regular street motor, not so much so. And part of that is because you have real packaging problems. You are lucky to get a decent header in there in the first place and not have it drag the ground. So this is the reason why way back, most of the engines, the OE, were run with cast iron log manifolds. Now, am I saying that's a good choice? Not even remotely. The log manifold, you're going to be lucky if when one is blowing down, you're not having a pressure pulse on 4 when it's trying to open. It's Just not a good idea. Would a better header help? Certainly. And OE even went to really short headers because that was a little better choice than the cast iron log, and I think it became cheaper to manufacture. We also have aftermarket short headers, aftermarket medium length headers, and aftermarket long tube headers. And if you're asking me what to run, the answer is always you want a long tube header. But a lot of times that doesn't fit. So even if you do math and figure out what's going to be perfect, you wind up having to compromise to make it work in the car. Some cars are so close to the ground that getting a long tube header in there, it's just going to drag. And so your only hope is a decent mid-length header. Now, will you get away if you want to run a real short header? Well, it's going to cost you. Each one gives you more and more. And the reason is because you're trying to generate airspeed in here. Just like we talked about airspeed over here for intake side, we care about airspeed in the exhaust system. The reason being is that airspeed going across the port is what's generating the vacuum we want to try and get in here to pull that last little bit of gas out. Now, the first goal, like I said, is just to get the exhaust gas out of the way. And the blowdown is also trying to keep you from having to push against any kind of pressure. That's part of the reason we open earlier is we blow it down so there's not so much pressure as the piston's coming up. I call that recovered horsepower. Instead of the other cylinders having to waste power in order to push the exhaust gas out. Because remember, if this is 9-to-1, we're going to get 90% of the gas out, and we only have the chamber left. And so we're having to push it out. We are wasting energy. This is sometimes called pumping losses. You are wasting a lot of energy just trying to get the air to move. That's all you're trying to do. And it stops being beneficial to the engine running well. So we want the tube to be properly sized as best we can. If you go really big tube, now most of the time it's hard to do, especially on a street application, a really big tube. First off, they don't fit the chassis well. They are big, trying to fold them around each other, it becomes a nightmare. You know, on some of them, you wind up going with one tube around the frame, then the tire burns against it. It's not a great choice most of the time. But if you go really big tube, what's going to happen? Well, you're going to lower the airspeed in the tube, and it's going to work better at high RPM and worse at low RPM, just like on the intake side. So we care about airspeed. Now, for the most part, when I look at an exhaust, I try and keep it about size to what the valve is. You know, if we're running a 165 exhaust valve on a small block, well, you at least want an 1 5/8 tube because 1 1/2 is technically smaller than the valve. You know, and if you can fit a little bit bigger or a slightly stepped header in, you're better off. If you can run a full length header, you are better off. And this is why I don't really have math, is I just make decisions based on what's going to fit and what's going to go. The other problem is you have to think about the whole exhaust. Now, most of our testing is done with open headers or open headers and an extension. But if you're in any kind of street car, you are running a full exhaust system. Hopefully, duals. If the car can't fit a dual exhaust, hopefully you're at least running a decent sized single exhaust. You know, if it's a 427 small block Chevy, you know, the very least, you're probably looking at a 2.5-inch pipe dual, or at least 3-inch pipe single. And you need to have some area. But your flow restriction isn't a lot of times the pipe itself. A lot of times the flow restriction is your choice in muffler. That's where you really see some changes happen. You need a muffler that flows pretty decently. As long as the exhaust is adequately sized, the muffler is higher flow, and the header is decent, you're going to make most of the power you're going to get out of the exhaust. Is there going to be some left? Sure. Each thing gives you a little bit more. I mean, going from the old cast iron manifold to almost any header gains you like 15 horsepower. You know, if you go to a long tube header, you might gain another 15. Maybe. You're not going to necessarily gain 30. You might only gain 20 going from cast iron to long tube header with an exhaust system. It's little amounts that you're looking at. Now, if you do a big tune, fancy exhaust system, will you gain more power? Sure. Even over a decent header, that can gain you another 10 or 15 horsepower. Now, some of that is starting to come into play with your thinking at TDC, but that's more race-oriented. This is not helping you in a regular motor. Your main goal is to get that exhaust gas to just flow out. It's not about the overlap. It's not about starting the intake cycle. It's about getting the exhaust gas out of there. That is what your real purpose is. So this is why adding a little bit of duration on the exhaust side on smaller cams can help. As you go up in size, you can, in camshaft, especially if you have a good exhaust system, a better flowing head, you don't necessarily need to bias the exhaust and create more problems at low RPM with overlap, because that's going to affect you down here. You want to kind of balance the motor out for what you're doing. And some of this is not about the math of it. It's just making some decent decisions. Well, what are my options for a header that fits well in my car? What is going to clear the ground? Am I in a lowered car? Am I, just off the ground? And so maybe I'm going to have to run a mid-length. And yeah, it's going to cost me power, but oh well. It's these kind of decisions. Do I have room for 2.5-inch dual, or if I'm running a really big motor, 3-inch dual, and a good muffler? I need to make a good decision on a muffler that's going to flow well. Because if you do, a single 2.5 pipe and a big motor and then some really quiet muffler at the end, well, yeah, that's not going to work well. Make a better decision. So that's why I don't get into exhaust a whole lot. It's really just about, we all know how this kind of goes. And there's plenty of dyno tests out there you can watch on exhaust system. And that's why, when you slightly have to dent a tube, it's not the end of the world to clear the steering. Because for the most part, it's still going to work pretty well. You're talking about little amounts with the exhaust system. Because like I said, technically it's going to force out a good chunk of it. That's why even cast iron log manifolds work. It is because initially it's not that fuzzy. Can you make it a little better? Yes. Is it the end all be all, my God, I need the exhaust perfect, otherwise I'm not going to make horsepower? No. And there, like I said, there's plenty of dyno tests you can watch that show that. And you can see what the motors do. You can see what happens with the power band. And I have seen some exhaust systems not carry well, but sometimes that's more when you're running like a lot of nitrous, where exhaust volume goes up, or you've made a bad decision on a muffler. And yes, mufflers are a personal choice because you also have the sound level involved. Well, that's also going to happen, remember, as you open this later and later. As you bias the exhaust on the camshaft and you open the exhaust valve sooner and sooner, you're going to blow down at a higher pressure. Well, that is also going to affect the sound of the exhaust system. And that is what you hear when you go to a, say a NASCAR race. As the car goes past, you can feel the pulsations in your bones. Well, that's a high output motor blowing down way early. That pressure pulse is way up there in pressure. And you can actually feel it. It actually shakes you. Well, that's what's going to happen. And if that's what you like, that's what you're looking at. You want to open that a little bit sooner. That's part of what, like the thumper cams did, is in order to make it sound, it opened, it added a lot of exhaust bias and opened the valve sooner so you had more of a thump to it, and tried to add a little bit of grounding at the TDC so your idle had that lope, because that's actually contaminated charge by you not getting it going well, because you need airspeed and you don't have it yet. You're at idle. So that's part of the reason they work in order to make that sound. And those are some of the decisions you can make depending on what you're using the engine for. A lot of times on the street, we want it fairly well behaved, but sound like it's more rumpity-rump than it is. And so sometimes you got to make those kind of decisions. But like I said, don't go by bias, because they work way different. And just try and choose a header that's appropriately sized. You know, if you are running some little nothing motor, you don't need a 2-inch stall adapted header tube on a small block Chevy to fit in there, where you had to cut a chunk out of the frame just to make it fit. Don't do that. You know, I mean, these are, the reason I don't talk about exhaust a lot is because these seem to me to be very common sense decisions that you're making. And unless you are way off, it's not going to be catastrophic. And so just try and make some better decisions. If it's a little cam, if you're talking 210, 220, yeah, you want some extra exhaust bias. Because on a soccer cam, they probably don't have enough exhaust flow. They are not probably blowing down soon enough. Why? Because they don't want the noise. So if you go a little bit bigger and you add a little bit extra exhaust duration, you will gain some extra horsepower. And again, like I said, there are dyno tests out there showing this. As you're going bigger and bigger, then it's less important. And some of that depends on if you're trying to adjust for the exhaust system. If you have to run a certain complete exhaust system with a fairly big cam on a fairly big motor, well, yeah, you might want to bias the exhaust a little bit to try and compensate for the lacking of the exhaust system and see if you can get that out of there. So these are the decisions that I recommend you make. And I know I kind of just glanced over this stuff, but I don't harbor a whole lot on exhaust side. I try and just make some adequate decisions. And I will tell you, if you want to get nitpicky about it, well, this is better than this, the bottom line is without testing it on something, you're not going to know. I have been way surprised at times at either how little I gained with a particular exhaust change or how much it didn't care about the exhaust. I mean, like I said, I've seen dyno tests. I think Engine Masters did one where they beat up the header and they could see almost nothing. And that kind of tells you about what's going on. As long as you're doing a reasonable job of getting the exhaust out and helping the motor out, you're going to be fine. You don't have to get too involved unless it's a full-out race, every last horsepower counts, and then yes, with tuning, with the proper adjustment, you may have to change the length of the tube because it's going to have to be tuned for a particular RPM, a particular car, and you're not going to really know without testing. So sometimes those things matter. The length of the extension pipe. But like I said, on the street, we're running a full exhaust. I'm going 15 foot out the back of the truck. So I have to make some good decisions. And so that's what I'm trying to tell you is don't get too hung up on exhaust. Just make some good decisions. We've all seen how this kind of goes. We all know the longer tube does better, and the medium-sized tube size is better for most street applications. Those old 1.5-inch headers, not the best decision. But something 1 5/8, 1 3/4, bigger motor. If you're doing a big block, high cubic inch displacement, 500 something, then you're probably wanting to go up to a 2-inch tube, but then you're running a 1/8/8 valve. Like I said, I kind of look at the valve side. So those are how I go about it. And I know some of you wish that I had some fancy math and told you how great it was and how you need to get this perfect. I don't, because you don't. I try my best to minimize TDC overlap because I don't find that it helps on the street. It's not going to certainly help you with a cast iron manifold. It's certainly not going to help you with a short header. You are going to have a tuned, full length, properly done header in order for that to start showing up as a help. So that's how I feel about exhaust. I know that's probably going to make some of you upset, but that's really how it goes. And I wish you luck on all your projects, and I hope you don't go down some sort of rabbit hole trying to design your exhaust system for 10 horsepower gain. So anyway, we'll talk to you later. If I didn't do something well here, leave me a comment. I'll see you later. Bye.